Hello, welcome to this video. This is for Math 3 students, and we're talking SOHCAHTOA. We are going to go ahead and review how to find trig ratios given a trig ratio. Yesterday in the last lesson, we talked about, okay, how do we dust off these cobwebs and deal with right triangle problems if I'm missing a side? Well, we can use Pythagorean theorem. What if I'm missing a side but I have an angle? Well, we can go ahead and utilize SOHCAHTOA. And yesterday we just practiced on kind of generating those ratios. Today we're doing that as well, but given a ratio, okay? So I just want to go ahead and remind you that a trigonometric ratio is a ratio of two sides of a right triangle, and there's three primary ratios: sine, cosine, and tangent. Remember, we have an acronym to kind of help us remember this, and that is SOHCAHTOA. So SOHCAHTOA, right, the SO stands for sine, and that ratio is opposite over hypotenuse, okay? Ka is cosine, that's adjacent over hypotenuse. And then lastly, TOA, that's tangent, which is opposite over adjacent. Okay, so SOHCAHTOA. And on all these problems, I'll recommend to you that you'll write down SOHCAHTOA. Now, remember too, though, that the side opposite and the side adjacent, they switch depending upon what angle you're in. So that's very, very important that you remember to label based upon what angle you're in, what angle you're looking at. Label. Okay, let's go ahead and talk about kind of our procedure today. So if we are given sine, cosine, or tangent of an acute angle of a triangle, we can find the other trig ratios of both acute angles by following these steps. One, we're going to go ahead and place the numerator and the denominator of the given trig ratio in the triangle. So based upon what I'm given, if I'm given tangent of A is equal to 2/3. Well, then I know that tangent is opposite over adjacent. So then the numerator is the opposite side, the denominator 3 is the adjacent side. We'll use the Pythagorean theorem to find the third side, and step 3, we'll go ahead and use our sine, cosine, and tangent definitions to find the other ratios. Let's go ahead and look at an example. So here's our first example, and it says, given triangle ABC and sine of A equaling 12 over 13, find the following in simplest form. Okay, well, I know that sine, right, is opposite over hypotenuse. And again, I'm just going to write this here so I can remember. Okay, so I know that this is opposite. I know that this is hypotenuse. Okay, so what angle are we in? A. That's right here. Okay, so the side that's opposite of A is right here. This is 12. The hypotenuse, always directly opposite the right angle. Okay, so this is 13. All right, well, I need to know what this missing side is. Okay, so I can go ahead. I'll just call this x. So I have x squared plus 12 squared is equal to 13 squared. Okay, and I can go ahead and solve for x by taking the square root of 13 squared minus 12 squared, right? Subtract the 12 squared, and then take the square root. Okay, and this gives us square root of 25, which is 5. Okay, so I can replace this. This is 5. Okay, so I found the missing side, right? And that should be old news. Like, you've done that a million times. You did it in 8th grade. You did it in Math 1. You did it in Math 2. Now you're doing it in Math 3. We did it yesterday. Okay, so I have my missing side. All right, well, now I want cosine of A. So again, okay, cosine, right? That is adjacent over hypotenuse. Okay, so this side, if I'm A, this is opposite. This is adjacent. So cosine of A, adjacent over hypotenuse. That is 5 over 13. Simple. Very simple. Tangent of A, well, that's opposite over adjacent. Okay, so opposite is 12. Adjacent is 5. Very easy. Sine of B. Okay, well, now I'm going to go ahead. I'm going to switch my colors, right? I'm going to scratch these out because now I'm in angle B. Okay, and the side opposite of angle B is right here. This is opposite. Okay, and the side that's adjacent, that's this side. This side's adjacent. Okay, so it changes. Remember that. It changes. All right, so I'm going to go ahead and erase this just so there's not confusion. Okay, so sine of b, that's opposite over hypotenuse. So 5 over 13. Cosine of b, that's adjacent over hypotenuse. 12 over 13. And then lastly, tangent is opposite over adjacent. So that is 5 over 12. Okay. All right, next example. I have cosine of b is 1/9. So again, I'm going to write up here, SOHCAHTOA. All right, I know that cosine is adjacent over hypotenuse. So again, I'm angle B, right, which is here. Okay, so I know that adjacent, that's 1, hypotenuse, that's 9. I need to go ahead and solve for this missing side, right? So step 1, find missing side. Okay, so I have x squared plus 1 squared, which is just 1, is equal to 9 squared. So we have 81, right? I'll go ahead and subtract the 1 squared on both sides. Gives us x squared is equal to 81 minus 1. So x is equal to the square root of 80. Okay, and the square root of 80, that's 16 times 5, so that's 4 root 5. Okay, 4 root 5, right? 16 times 5. Okay, so 4 root 5. All right, I have my missing side. Really, I think that's the hardest part, because now all I have to do is just go ahead and fill these in. And this is what we did yesterday. So sine of A. Okay, so again, I'm not here, right? I'm in this angle. So sine of A, right? Here's A. Okay, so 1/9, right? Opposite over hypotenuse. Okay, what's cosine of A? Well, adjacent over hypotenuse. Okay, so that is 4 root 5 over 9. All right, tangent of A. That is opposite over adjacent, right? Opposite over adjacent. So that's 1 over 4 times root 5. And we do want you to rationalize in these examples just to practice that. So we get root 5 over 20. And if you're unsure how I got 20, it's 4 times 5, right? 4 times 5. So that's root 5 over 20. Okay, sine of B. Well, sine of B, okay, so again, I'm up here now. Okay, so side opposite, that's 4 root 5. 4 root 5 over 9, which is the hypotenuse, opposite over hypotenuse. All right, and then tangent of B. Tangent of B is opposite over adjacent. So 4 root 5 over 1. Okay, which is just 4 root 5. All right, again, make sure, 1, you solve for that missing side. Step 2, make sure you know what angle you're looking at. And then step 3, label, okay, and find those sides. All right, here is a practice problem for you. Please pause this video. I want you to go ahead and try this, and then hit play, and you can give this a go. Okay, so hopefully you paused it. Here is the solution. The missing side was root 8, which is 2 root 2. And here are the trig functions. All right. I have one more example and then one more practice problem, and then we'll call it a day. Here we are told that tangent of A is 3 over 7. Okay, so tangent, I always just want to make sure. SOHCAHTOA. So tangent is opposite over adjacent for A. So here's A. Okay, opposite is 3. Adjacent is 7. I'm missing this side, which is X. Okay, so I know that 3 squared plus 7 squared is equal to X squared. All right, so that would be 9 plus 49 equals X squared. So X is equal to the square root of 58. Okay, so this is root 58. Okay, and I can't simplify that. I can't reduce it. So now I'm going to go ahead and I'm going to fill in these values. Okay, so sine of A. So opposite, which is here, over hypotenuse, 3 over root 58. Okay, so I'll rationalize. And we get 3 root 58 over 58. That easy, right? That easy. Okay, next, cosine of A. Well, that is adjacent over hypotenuse. So 7 over root 58. Okay, so I will rationalize. Okay, so we get 7 root 58 over 58. There it is. Next, we want sine of B and cosine of B. Well, remember, they're reciprocals of these. So I've already put in the hard work. Not reciprocals. They're complementary angles, so they're exactly the same, right? No, that's not right. Sorry, I have my mixed up. Okay, so cosine is sine. So this is 7 root 58 over 58. This one is 3 root 58 over 58. Okay, and then last but not least, tangent of B. Tangent is opposite over adjacent. So if we are B, right, here's B, opposite is 7, adjacent is 3, so that is 7/3. That's a 3, I promise. 3. Okay? All right. Here is a practice problem. Please pause this video. I want you to go ahead and give it a go. A lot of us struggle with just finding that missing side. So pause the video. I want you to try this, find that missing side, and then unpause it, and then see that missing side. All right, hopefully you paused it. Here is the solution guide. Don't look at this side. Don't look over on the left, but just look. Okay, so that missing hypotenuse is 29. Okay, now I want you to go back. I want you to finish the rest of it. Find all the trig functions, okay? So pause it again. All right, hopefully you've done that. Here is, again, the solutions. There you are. And that is it. I just have one last kind of closure for you that I think is important. Here it says match each side of the right triangle to the correct description. So all of these sides, which one's the hypotenuse, which one's the side opposite of A, which one's the side opposite of B. Again, really getting us to be able to identify those correct sides. So pause the video, try this, and that'll be it. All right, and here is the solution. So you should have gotten that, okay? That is it for this video. Thanks for joining. And join me in the next video to go ahead and talk more triangle trigonometry. Catch you next time. Peace.